So we are going to be slowly stepping away from Newton's first law and approach Newton's second law. Now, in order to understand Newton's second law, we can't forget Newton's first law. So an object at rest remains at rest unless acted upon by an unbalanced force, or an object in motion remains in motion unless acted upon by an unbalanced force. But Newton's second law is a simple mathematical equation, which is force equals mass times acceleration. Okay? Now, that seems simple, and the math for it can be simple. But to really understand what it means takes a lot of time with the math that we were doing and understanding the motion of objects when they're accelerating and really what acceleration looks like and what causes it. So bear with me, because this is one of the hardest things for me to explain. Now, a normal physics teacher who went to school for physics, they would probably be like, it's super simple, I can explain it really easy. But it's a challenge for me, so bear with me, okay? So we're gonna start by talking about gravity. Now, to start with gravity, I'm going to drop this ball, and I want you to tell me if the ball is moving at a constant velocity after I drop it, or if it's accelerating. So I'll do it one more time. Is the ball moving at a constant velocity when I drop it, or is it speeding up as it approaches my other hand, my bottom hand? Okay, so if the ball was not accelerating and was moving at a constant velocity, or if gravity moved things at a constant velocity or a constant speed, that means that if I were to jump off the desk and land on the ground, let's say I was moving at 2 meters per second, I would continue to move 2 meters per second as I approach the ground. But that's not true, because if gravity was a constant velocity, that means that the speed that you hit the ground jumping off of a table. Hey, I can't talk, sorry. The speed that you would hit the ground after going on the table is going to be the same as if you were to jump off a roof and hit the ground. So it's just going to be a constant velocity, but that's not the truth. Gravity is an acceleration, okay? So here's the deal. If we drop a ball from anything and we use the Earth's gravity moves things at about 10 meters per second squared. So that just means that every second that goes by, whatever we're dropping is going to be moving an additional 10 meters per second downward than it was previously, okay? So that should make sense. After 1 second, it's moving at 10 meters per second. After 2 seconds, it's moving at 20 meters per second. And it's continuing to go faster and faster. At 5 seconds, 50 meters per second, right? So that's nice and simple, right? But if we were to discuss the distance that the object travels, this is where things get a little more complicated, right? So bear with me. Between 0 seconds and 1 second, the object went from moving 0, not at all, to 10 meters per second. So in 1 second, it went from not moving, and it hit every speed in between 0 meters per second and 10 meters per second, okay? So that means that the object is dropping like this, right? Faster and faster and faster. And we can see that here, dropping faster and faster and faster. But what does that mean about the distance traveled? So the average speed between 0 seconds and 1 second is going to be the average between 0 meters per second and 10 meters per second, which is going to be an average speed of 5 meters per second, right? So that means if I move at an average speed of 5 meters per second for 1 second, I'll have moved 5 meters. Okay? So let's think about that again. If I move between 0 meters per second and 10 meters per second in 1 second, my average speed for that is 5 meters per second. So in that amount of time, I'm going to be moving, or in 1 second, I'm going to be moving 5 meters. So that's weird, because my speed at that point, after that 1 second, is 10 meters per second, but I've only traveled 5 meters. And I'm going to prove that to you with algebra now, okay? So distance equals 1/2. The reason for this 1/2 is going to become clear right now, because think about this. 1/2 of 10 is 5. So the 1/2 is going to be important. So d equals 1/2 acceleration. The acceleration to gravity is 10 meters per second squared. Okay? So we're going to set this up where d equals 0.5, because it's nice in the calculator, right? 1/2 is 0.5, multiplied by 10 meters per second squared. And then the time is going to be, sorry, should have done time. The time is going to be 1 second, right? So 1 second squared. Lucky for us, 1 squared is still 1. So, what is the distance traveled by something dropping due to the Earth's gravity? Anything dropping due to the Earth's gravity? 0.5 multiplied by 10, or 1/2 multiplied by 10, is going to be 5. And since we have second squared and second squared, we cancel out the second squared, and we're left with meters. All right? So an object that is dropped for 1 second, no matter what it is, on Earth, will move 5 meters down, or about 15 feet. So that is a far distance. So falling for 1 second is a far, far distance, okay? So you're going to watch these videos, and I will continue a new video after this.